Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem: search and rotated sorted array. Okay, so what the problem is saying is we'll be given an array, okay, which is a rotated and sorted array. Okay, so if you see that this part is sorted and this part is sorted, okay, but if you see the complete array from complete array's perspective, then definitely it's not sorted because it is rotated. This array was rotated in the right direction by six places. Okay, by six places. Initially, you can just assume the array was something like this: 5, 6, 7, 8, 9 and 10. Okay. Okay. So now how to so what the problem is saying is, since we are given this rotated sorted array and we'll be given a key, okay, and we want to find this key, right? We want to find this key in this particular array. Okay. Okay, and if we found the key, then we want to return its index basically. So if the key, right, the key is 3 and is found at the last position, which is 8th position, right? Okay, so this is the ask. Okay, now how can we solve this problem? So first of all, let's see the naive approach, wherein what we are going to do, we're just going to iterate through the array, right? Iterate through the all the elements of the array, right? And just compare this key with the particular element. Wherever we find the key, we return that particular index. Okay, so this is going to take us what? O of n time complexity. Okay, just it's a linear search, right? It's a linear search. So now, since the problem saying is that the array is sorted, right? It is rotated, but yes, if you see there are two parts which is sorted, and definitely we can that is why we can leverage the property of binary search to solve this particular problem. Okay. Since the array is sorted and like in parts, right? In parts, right? And we want to we want to search an element, then definitely we'll use binary search to solve this problem. But yes, it is going to be some modified version of binary search. Okay. So what we're going to do? So we are going to take definitely we are going to take L pointer and R pointer, and we're going to find the mid. So L is 0, R is 8. We're going to find the mid. What is mid? L plus R by 2, which gives us what? 0 plus 8 by 2, which gives us 4, right? 4. So mid is pointing 0, 1, 2, 3, 4. Mid is pointing here, right? Mid is pointing here. Let me remove this part. Okay, yeah. So mid is pointing here at this particular position, right? At this particular position. Now, what we're going to check here is, first of all, is array of mid equal to key? No, it is not. So what we're going to do here, we're going to check is array of mid greater than array of L? What we're going to check is array of mid greater than equal to array of L. Why we are checking this? Because we want to know where can the key lie. Because here it may be the case, right? It may be the case that this array of mid is not greater than array of L. Because for example, if this was the case, right? Let's say 5, 6 and 1, 1, 2, 3 and 4, right? 1, 2, 3 and 4. For example, 0, 1, 2, 3, 4, 5, 5, right? And mid was somewhere here, right? Mid is somewhere here. So in this case, this condition fails because array of mid is not greater than array of L, right? In this case, we want to search the element, right? Search the element in this particular area, okay, in this particular region. Okay, that is what we are checking. Since this is rotated array, that is why we want to check this particular condition. Okay, so let's see how it works. Okay, so array of mid is greater than array of L. Yes, it is. Yes, it is. Then we are going to check. Okay, what are we going to check here? What are we going to check here? We are going to check here if array of key, if key is greater than if key is greater than array of L, we want to check whether the key lies in this area or not. Array of L and then key is less than array of mid. We're going to check, right? Key is less than array of mid, right? Okay. So if this is the case, for example, is this the case? Is this the case? Key, okay, is key greater than array of L? Key, which is 3, is greater than array of L? No, it is not. No, it is not. And also key is not, yeah, definitely, yes. This matches array of key is less than array of mid, but this fails, right? Key is not greater than array of L. So this condition fails. So what we are saying is we are going to increment our L, right? What we are going to do is else part, we are going to say L equal to mid plus 1. So since this key, it is not greater than L, right? It is not greater than L. That means this key is not in this range, in this particular range. That means the key is definitely in this particular range. So what we're going to check is, what we're going to do is we are going to take L equal to mid plus 1. So mid is here, we'll say that L is here. L will be here. So now our search region, search of area is this particular region, right? L and R, right? L and R. Okay. So now what we are doing, what we are going to do, what we are going to do again, we are going to check is R of this particular case, R of mid. So first of all, we are going to calculate mid. L is here, R is here. So what is mid? Mid is what? L is what? At 5 position, 5 plus 8, right? Divided by 2, which is what? 13 divided by 2, 6. 6. Mid comes as 6. So mid will be pointing here, right? Now what are we going to check? We're going to check this. Is R of mid greater than R of L? R of mid is this, R of mid is this, and R of L is this. No, it is not. It is not. So this else condition. Else condition to this particular if will be, let me write here. Else condition to this particular if will be if 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 key is greater than is if key is greater than R of L, right? R of L, R of L, and key is less than, sorry, not R of L. It is going to be, sorry, not R of L. It is going to be mid. R of mid is key greater than R of mid, and key is less than R of R, right? Key is less than R of R, right? So if this is the case, let me check. Let's see if this is the case. What is key here? Key is 3. R of mid is this. Definitely key is greater, right? Key is greater, and it is also less than or equal to, we are going to say less than equal to, right? Key is less than, key is what? Key is 3 and R of R is 3. So key is less than equal to R. That means again, it is in this particular region. If this condition had failed, the key would have been in this particular region, right? But yes, since this condition is matching, right? It will be in this particular region. Okay, so what we're going to do? What we're going to do? L equal to mid plus 1, we are going to say mid plus 1. If this condition had failed, this particular condition, then else would have been R equal to mid minus 1, we will say. Okay, now we are going to say L equal to mid plus 1. So L is going to be here, right? Okay, L is going to be here. So let's calculate mid again. So mid be what? Mid will be what? L plus R by 2. L is 6 plus R is 8 divided by 2, which will give us what? 14 divided by 2, which will give us 7. Now 7. So what is 7? 7 is again mid is here, right? Mid is here, pointing at the along with L, basically along with L. Wait. So uh, 0, 1, 2, 3, 4, 5, 6. Mid was here. Mid was here, right? Mid was here. So yes, so it will be what? Sorry, L equal to M plus 1, right? So 7 plus 8, not 6 plus 8. It would have been 7 plus 8 divided by 2, which would have been 15 divided by 2, which would have, again, it would have been the same, 7. So L and M both are pointing at the same location, we will say. L and M both are pointing at the same location. Now, we're going to check again, is this particular condition, is R of mid greater than equal to R of L? Yes, it is, because both M and L are pointing at 2 only, right? Okay, and what we're going to check here is key greater than equal to R of L. Is key greater than equal to R of L? Yes, key is greater. Key is 3 and R of L is this 2, right? And is key less than equal to R of M? Is key less than equal to R of M? R of M is what? R of M is 2. Key is not less than equal to R of M, right? If key is not equal to less than equal to R of M, that means key is should be in this particular to the right side of 2, basically to the right side of 2. So what we are going to do? We are going to say this condition will be executed. L equal to M plus 1 we are going to do. So L was here. Now, sorry, L was here, right? So we are going, and M is here, right? M is here. So L will be M plus 1, which will point at here. Which will R and L both are pointing at the same location. Now again we are going to calculate mid. L plus R, 8 plus 8, 8 plus 8 divided by 2, which will give us what? 8 again, right? 8 again. So mid is pointing here, and our condition, the initial condition will be if R of mid is equal to key, right? Which is the case, and we are going to return mid, which is a position. Okay, so I hope you have got the intuition. Okay, so I think you'll understand better with the code. Okay, so let's go and code. Before going to the code, I'll request you please subscribe to the channel, like the video. Let's quickly see the code. Int L equal to 0, int int R equal to air dot length minus 1. Okay. Now what are we going to check here? While the standard binary search checks while L less than equal to R, right? First of all, we are going to calculate the mid equal to, let's say M, right? L plus R by 2, we are going to say, right? L plus R by 2, we are going to say. And first check will be if R of M, if it is equal to key, that means we have found the key and will return the position which is mid, right? If this is not the case, we are going to check here. We want to check the range basically. If R of M, if R of M, if it is greater than equal to R of L, right? R of L. Okay. So this, right? Initially, we are checking if R of M is greater than equal to R of L. Yes. So we are going to check here in this range. Okay, in this range. So how are we going to check here? So we're going to check if key is greater than equal to R of L. We're going to check whether key is in this range or not. We're going to check here, right? If key should be less than equal to R of M, right? Right. So yeah, so we are checking here. If this is the case, that means we are checking if the key is in this range. If the key is in this range, then we want to reduce our R basically, and we want to bring it here or in this particular position, bring it here, right? R. So R equal to mid minus 1, we are going to say. R is equal to mid minus 1, right? If key is not in this range, then we are going to say else L equal to mid plus 1. That is, key is in this particular range. We are going to say in this particular range. Okay. Now to this condition, for example, if R of mid was not greater than equal to R of L, then we are going to check in the second half else part. And what we are going to check here, if key is greater than equal to R of mid and key is less than equal to R of R, we are going to say. Okay, if it is in this range, right? If it is in this range, for example, if it is in this range, then we want to, our mid is here, and if it is in this range, we want to update our L, right? We want to update our L. So what are we going to do? L equal to mid plus 1, right? Else R equal to mid minus 1, we are going to say. Mid minus 1. Okay. And finally, what are we going to do? Simple. If we didn't find the element itself, then we are going to return minus 1. That's it. Let's compile. So what will be the time complexity? It is going to be O of log n. Okay. To search an element in a sorted array, binary search takes O of log n time complexity. Let's submit it. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Okay. Let's quickly see the C++ code. Yeah. So yeah, the C++ code is almost same. Only it changes here. Array of size. There in Java, it was array of length. In array of size. Rest, I've already explained everything. I'll attach the code in the description. Okay. Okay. Thanks for watching. Please don't forget to subscribe to the channel, like the video. I wish you a happy, healthy, wealthy, and a great day. Thank you so much.